Did you know if the Earth stopped spinning instantly, inertia would create winds at speeds of 1600 kilometers per hour? Hi and welcome back to an Engineering Odyssey with your host Gaff and Pats. 1600 kilometers per hour is a crazy amount of speed, is it not?
Yeah, it is quite immense, to be honest. It's caused mass devastation to everything. People,
exactly.
Trees, buildings.
Everywhere you look will just be rubble. Just piles and heaps of like concrete and just
everything will just be uprooted and just sent across. Actually, fun fact about that, it wouldn't actually leave the planet because I think breakaway velocity is around 20,000 plus miles an hour or something.
Yeah.
So it wouldn't actually leave the planet, but it would.
Nothing will be flung off. It will just literally be heaps and rubble.
And buildings like they're normally seismically qualified, not saving them on that 1600 kilometers.
Not. Yeah. If you're in a plane or the International Space Station, you have some chance of survival, I guess. You're not on the surface, so you're not going to be crushed by anything crazy, but you'll have to navigate through storms. You'll have to navigate through fires and all sorts.
Well, that's if you're on a plane. So there's less chance of survival on a plane.
If you're in the International Space Station, you'll just be watching, and I don't even know what was going through your mind at that time.
In both instances, if you're on a plane, there's nowhere to land, so it's game over. If you're on the International Space Station, there's nothing to come back to. So very fun fact there. Hope you enjoyed.
It's a big downer for the start of the episode. Yeah. But hopefully it was just an interesting fact that people enjoyed.
Yeah.
However, let's just get straight into this episode and talk about the title, To the Moon and Back.
So with that title, we'll be discussing everything in between, and hopefully that brings us nicely into the topics we're going to talk about today.
Yeah. So the first topic we'll actually be discussing is Boeing, particularly Boeing 737 MAX aircrafts. Yeah. And that's been in the news lately.
They've had a few incidents.
Definitely, yeah. We'll discuss what happened and when it happened.
Yep, the international response.
We'll also discuss some of the technology side of things.
Some of the technological downfalls is where you go with that. So yeah, the engineering issues.
We'll touch on the engineering issues, and why these incidents happen eventually.
Yeah, so should we just get cracking straight into this?
Let's do this. So Boeing 737 MAX, they're a type of 737 aircraft, which Boeing already has, but these were, let's say, improvements.
There's two types of well, there's 8 and 9.
Yeah, so there's 737-8 and 737-9. And these aircrafts, like I said, they're pretty brand new. But the first incident happened on the 29th of October 2018. And this was on Lion Air flight, where the flight crashed into the Java Sea 12 minutes after takeoff.
Not long
at all. Yeah, I mean, it just took off, and within 12 minutes, it was already crashed. All 189 passengers on board had been.
It's a fatality. They all lost their lives. Yeah.
Yeah.
The plane was less than 4 months old, so that's very brand new. So the second incident, which prompted this international response we're going to get onto, was the Ethiopian Airlines Flight 302. It took place on the 10th of March 2019, so just at the start of last month. It crashed shortly after takeoff as well, so similar incident. It was en route to Nairobi from Addis Ababa, and 149 passengers and 8 crew members were all dead. So another very devastating
crash. Both of these crashes were devastating, but it's the Ethiopian Airlines flight, the most recent one. That's what prompted investigations further into Boeing and why this was happening. The incidents were almost identical.
And so much so that I forgot to mention here that the Ethiopian Airlines flight was also less than 4 months old, so just brand new.
Yeah, these planes were brand new. They just come off the shelf from Boeing.
That's probably what's prompted the investigation into them, because they're so brand new. It seems like there's a fundamental fault because both of them crashed after takeoff. We'll get into it further. They were both similar issues that brought the planes down.
At the start, there was concerns of the pilots being the issue. However, with more news emerging as of recently, It's actually turned out to be the fact that the certain systems within the aircraft had failed, and although pilots had tried to respond in a way to fix the issues, it wasn't enough.
It seems like a bit of a cop out that they said that it was the pilot's issue straight away. And
Yeah, I think any corporation would just kind of try and back themselves up first. But
I assume
as an issue as big as this, it doesn't.
I assume after they recovered the black box, they could sort of.
Yeah, definitely. Let's look at some of the international responses from the issues.
Mm-hmm.
So China, or specifically, just let's say Asia, almost 96 jets in Asia had been grounded following this incident. Especially from the three big airlines: China Southern Airlines, China Eastern Airlines, and Air China. So obviously a massive hit to the Chinese economy, and these airlines in particular.
And it was between them three, out of the 96, it was 40 planes that they had to ground. So yeah, massive. The UK also took a similar approach. So Britain's Civil Aviation Authority said in a statement that it would halt commercial flights using the 737 MAX 8 from any operator arriving, departing, or even overflying UK airspace. So they took a no action, nothing going through here.
The same with the EU, the European Union Aviation and Safety Agency. They suspended all the Boeing 737 MAX 8 and 9 flights as a precautionary measure.
So the US actually took a different approach. Obviously, Boeing being a US company, it's tried to sort of avoid it first. So the Federal Aviation Administration, so many tongue twisters here, initially stated it had not received enough evidence to justify taking action against the 737 MAX. But then on March 13th, President Trump announced a policy reversal and said the US would ground the aircraft as well.
Which is a huge hit on the US economy, Boeing being a US company. And it trades on the New York Stock Exchange. It's a really big hit. It's a big hit.
Yeah. Almost all of the 350 aircrafts that Boeing had sold have now been grounded and suspended. And under investigation. Yeah.
And like I said, the Boeing share price dropped instantly with these open investigations continuing on. And hopefully we'll see responses from Boeing in a positive way through improving these planes in a technological way, and then hopefully
moving on, and let's see what they can find in their investigations. So what have they found so far? Technologically, what went wrong? Let's delve into this now. So on first sort of investigation, they found it was a safety feature. So there's this component called the Maneuvering Characteristic Augmentation System. That's a mouthful.
Let's just call it the MCAS.
MCAS, that's what it's abbreviated to. So it appears to have sent both planes into their fatal dives as pilots struggled to keep it aloft.
Mm-hmm.
So the MCAS is meant to prevent the plane from stalling or losing lift, and that's sort of what's the issue, because both of them were takeoff. It's straight after takeoff, and I assume both planes have not been able to stay up.
So the MCAS was actually introduced to these Boeing aircrafts because these Boeing aircrafts were actually different to the previous models. So they became a lot heavier, more fuel-efficient engines. They changed a lot of the aerodynamic qualities of the aircraft. And all of this can cause the plane's nose to pitch, especially in certain conditions during manual flights. The way the MCAS works is by...
Sorry, just to stop you. During manual flight is very important, because when you take off and land, that's manual flight.
Exactly.
So, carry on, sorry.
The way the MCAS works is by using angle of attack sensors on the aircraft. This tells the MCAS to automatically point the nose of the plane down if it is in a danger of going into stall.
Yeah. So this is done through horizontal stabilizers on the plane's tail, which are activated by the aircraft's flight control computer, basically. It clearly seems like this was the main issue that brought them 2 flights down.
Yeah.
The software was designed to automatically and only in... software was designed to work automatically, but only in extreme situations. So for that reason, Boeing had decided that there's not going to be that many extreme situations, so they didn't even add any new training for the pilots. And going further than that, they didn't even add it into the new flight manual. They didn't even mention it in the system flight manuals, which is ridiculous. It's a massive miss out.
Yeah, definitely. It's actually, we should actually make a point here that this is a problem with a lot of engineering companies. Training is one of the major things that before going into anything else innovative,
Carry on.
I got this word wrong last time.
Yeah,
as
last
well.
time. Yeah.
Anything
Anything
that
new.
includes innovation.
Yeah.
You need to have training. Because you need to expect people to know how to use it, and then if there's any issues as well, they need to know how to handle that.
Yeah, and going off of that, a spokesman for the American Airlines Pilots Union told Quartz that the training prior to the Lion Air crash, so that's the first one, the pilots, like the qualification or the lessons they had was an iPad lesson for an hour.
Imagine that.
Yeah,
I've downloaded flight simulators on my phone and iPad and stuff.
This is like this basic stuff that they went through.
Exactly. But yeah, so the MCAS would kick in every time a pilot tries to straighten the plane out.
Yeah. So it was malfunction. It was just kicking in.
This caused a tug of war kind of thing. The pilots were trying to fix it. The MCAS would reactivate and bring it back down, and eventually this continued over and over again until the plane had just crashed.
Yeah. So just reiterating the whole thing, a plane normally stalls when it's in when it's facing upwards because the engines are having to produce a lot and it's not getting as much air in. So these planes, this MCAS system, is designed to just shoot the nose down straight away so that you're not facing too far up. But obviously on takeoff, the pilots know what they're doing. The manual flight, they're facing upwards basically, and this MCAS unit was just completely contradicting any move that the pilot tried to make and just pull them down, and that seems to be the main issue, I guess.
Let's look at some logistics here. The 737 MAX 8 is designed to be similar enough to the 737. So, as you mentioned before, all the previous pilots who had training on 737s, they wouldn't need to have further subsequent trainings to fly these new aircrafts. They would be capable of doing so.
And a very important comment here can be made is the airline did this to save money. Yeah. So they didn't need to retrain their pilots, because it's technically classed as the same type of plane, and so they just to save money, they missed out a massive thing.
However, these planes are different. They're larger engines, placed they're farther forward on its wings.
Yep.
And pilots need to know how to control these. So without training, Boeing are just setting themselves up for devastation.
Yeah, it's latent error traps there that are quite clearly present.
These larger engines, they increase risk of the plane stalling.
You said
because
this,
of the angle.
Yeah, you mentioned this before. These big changes that they made on the plane, even though it stayed as the same type, they were massive changes that actually changes the dynamic of the plane. So it was a massive mistake.
But the main thing is that this is still an ongoing investigation. Obviously, there's a ton of fatalities, and these investigations, as further developments continue to emerge,
always changing.
We'll have more information and see what Boeing will actually do in response to this, how they can engineer their aircrafts to be more responsive in a better way, and furthermore, just including the training as well. The training is a big aspect. You can make things automatic. You can make things have different computers and software and whatnot. But you need manual override when in the situations where
it's needed. This was needed.
This was a situation where it was needed.
After 3 or 4 times, I'm not sure.
These pilots are trained and they should be able to land a plane.
And I was also going to say, I'm not sure how many times the pilots had to fight the system. But there should be a manual override which allows the pilots to turn...
I actually have it noted down.
Oh, do you?
Yeah, these pilots and the MCAS were in a tug of war, and this tug of war cycled 21 times. This was the Lion Air flight. So this was the flight that happened last year. 21 times. So imagine 21 times going back and forth. And the flight was only 12 minutes. So within 12 minutes, they
had to do it 21
this tug of war happened.
Due to no training, even if there was a manual override system, they didn't know about it.
So... that's the Boeing 737 MAX incident. Like I said, it's an ongoing incident.
So
new developments are coming out regularly.
Investigations ongoing. Could be anything in the next few weeks or months.
But leaving planes behind, let's take this further into space and talk about something a little bit interesting. It's been in the news. Hopefully most people will know of it. If not, there might be a potential space race reignited.
Yeah, the space race looks like it is being reignited by the US. So getting straight into the first question that we have here is who ignited it and what's happened and why, basically. So the Trump-Pence administration has said that it wants to put astronauts back on the moon in the next 5 years, and this is a quote, by any means necessary. So
I mean, it should be pointed out that not all presidents since Bill Clinton have mentioned that they want to get astronauts on a certain.
Yeah, so we'll get into this a bit later on. Each president changes, or they have their own idea of what they want to do in space. So that's a big
so it's
issue.
not unique to Trump and Pence that they want to go back to the moon.
Exactly. But yeah, so at the National Space Council in Alabama, Vice President Mike Pence said, "We're in the space race today, just as we were in the 1960s." So he's literally gone out and said it. They're in the space race. And
in a nod towards to the words of Neil Armstrong, he actually added to those words, and he said, "It's time for the next giant leap."
Yeah, just ripping off them. That
exactly,
brilliant quote. Yeah.
But does this mean the space race is now reignited? Are we going off the words of Mike Pence and the Trump administration, and reigniting the space race that we saw back in the Cold War era?
Yeah, so getting on to what the purpose of it is. So this summer 2019, so the summer of 2019, I should say, marks the 50th anniversary of the first manned moon landing. So that was Neil Armstrong and Buzz Aldrin, obviously. So since the last astronaut, so that wasn't actually the last time astronauts walked on the moon. So since the last time they did, which was in 1972, no country has made a serious attempt to send humans back to the lunar surface. And like you said, presidents do take it seriously to, their mission, whatever it may be. They do take it seriously to send people, but no one has actually gone as far as actually making it happen. So yeah.
And over the last few years, NASA has actually switched focus back and forth from the moon to Mars. This is a big victim of changing presidential administrations mainly. So obviously Barack Obama, he favored Mars as the next destination for astronauts, whereas Trump, now in the White House,
Whitehall, yeah,
he favors the moon.
All right, yeah, and due to this constant switching back and forth, there's fears that the US may be falling behind in their space race. And as President Trump's desiring for a flagship project to champion as he mounts a re-election bid, that's what everyone thinks is behind this project. Whatever it is, it's a smart move. If he can make it happen, it is a massive bid for his re-election or whatever. But yeah, his project is to send Americans back to the moon. Just as with the previous space race, everyone is asking, are they going to be competitors, and who are they going to be?
Yeah, definitely. There's definitely going to be competitors. Obviously, the old age competitor of the United States, Russia. Mm-hmm. They already have a lot of space.
Back when
back then,
the
USSR, yeah. But Russia being the successor of the USSR, they still have a lot of rivalries with the United States. They're very active in space, being one of the main players in the International Space Station as well. Mm. Also, we've been seeing China. They've been increasing their space activity through satellites mainly. Yeah. But both countries and now the United States have all declared that they are interested in assembling some sort of some sort of space force.
Yeah.
And this was also announced by President Trump when he first got into office, that he wanted to create a US Space Force.
It's interesting that he has said he wants to put Americans on the moon. Do you think he'll do it with this Space Force, or do you think he'll do it outside of that and try doing it himself and sneaking past?
I think it will be separate. I think it will be two separate entities, obviously NASA being more for exploration. Mm-hmm. But the US Space Force is going more towards weaponizing space. And all three of those countries have shown interest in doing that.
Right, that's interesting. So going on to NASA, because they're the biggest player in this. How are they going to prepare for all of this now?
Yeah, so NASA have had issues with funding. They're obviously with changing presidents.
Yeah, it always changes how much each president elects to give NASA. There are obviously reports that NASA, so Trump's trying to cut budgets elsewhere to give NASA more money to try and get this project done. Yeah. But yeah, we'll just see how that plays out, I guess.
But NASA has responded to this, to the US administration, and they have said that they are planning to do manned missions by 2028, by first putting a gateway station in orbit around the moon by 2024. The US government wants to see this timeline accelerated.
Yeah, so this was obviously said in this National Space Council in Alabama. So Mike Pence has said, in order to accomplish this mission, NASA must transform itself into a leaner, more accountable and more agile organization. and also that they must adopt an all-hands-on-deck approach, and that's direct quotes from Mike Pence. Mr. Pence has also warned that if NASA cannot put an astronaut on the moon by 2024, they need to change the organization, and that seems like a big
Quite
threat tonight.
threatening
Yeah.
tone, yeah.
So
Quite a threatening tone for the vice president to take, but clearly shows that there's a lot of drive and initiative to actually achieve this.
yeah, and he's clearly favored the moon here, favored the moon for their main mission, because he said change the organization, not the mission, so they won't be changing halfway through. So yeah.
Following on from Mr. Pence's announcement, the NASA administrator, let's hope we get this name right, Jim Bridenstine.
Yeah, that's it.
Jim Bridenstine said in a Twitter post, "Challenge accepted. Now let's get to work."
Yeah, so they've clearly,
They've taken it on
they've
board,
taken the call.
and hopefully we'll be seeing in the next few years something from NASA, something new, something, we'll be seeing men on the moon,
Hopefully.
or maybe women.
Yeah, hopefully, definitely. There was obviously the spacesuit walk that just happened recently, and there was all the controversy behind that, but we're not talking about all that now.
Mm-hmm.
Yeah, so the program is likely to be in the tens of billions of pounds and
Dollars.
dollars. Sorry, yeah. It's going to be very expensive to do this.
Yeah. The shuttle mission ended in 2011 because of NASA struggling to actually devise a suitable project, and they had issues with rockets. So since 2011, they've actually been using Russian spacecraft to get into space, and up until 2018, they've realized that this has cost the administration a lot of money. They do need to be developing their own aircraft, and they've put forward contracts to bid for by I think 6 other companies.
Yeah, I think it's 8 others. Is it 9? I'm not sure. In order to get astronauts on the moon by 2024, NASA have said that a new mega rocket will be needed, and that's where all these other companies come into play. And because it obviously needs to be developed a lot faster, they need a lot of help. So yeah, it says in the next point, NASA named 9 US firms, including Lockheed Martin Corp, that would compete for funding under the Space Agency's renewed private-public partnership, which happened not long ago, for developing technology to explore the lunar surface.
Mm-hmm. They're also working alongside Boeing. So obviously mentioned before, Boeing have their own issues to worry about, but they're working alongside Boeing, developing its next big rocket and capsule vehicle. This is called the SLS, the Space Launch System, and it's designed to carry more crew and more cargo beyond Earth's orbit.
We'll get onto this in a bit. Just a quick side note on the Boeing thing. They'll definitely still want to be involved no matter what's going on with their planes, because they were involved in the first one in 1969, so I assume they'll want to play a part again.
Yeah.
So it's also working with other companies. So NASA's also working with other companies such as SpaceX, Boeing, Lockheed Martin Partnership, United Launch Alliance. God, that's a mouthful. So it's trying to get an uncrewed capsule into space by 2020. And in March 2018, NASA said it was considering using private rockets instead to launch its new Orion capsule around the moon without a crew on a test flight next year. That's all what NASA's trying to get across.
Jim Bridenstine actually expressed confidence that the SLS is ready and would be good enough for the job. He stressed that the need for an outpost with astronauts near the moon is definitely something that the agency has to consider.
Yeah, that's just Jim Bridenstine pulling away from the whole private rockets, considering that they're just going to stick with the SLS system for
Essentially, it'll be sort of like a fueling station, like a motorway service station
in
space.
Yeah,
by
big
the moon.
one though. Yeah.
Yeah.
So with all of that being said, there still remains big doubts over what is possible. So Jonathan McDowell again, here comes a massive tongue twister, Harvard Smithsonian Center for Astrophysics in Cambridge, Massachusetts. God, I struggled. Said, I will be astonished if this happens, and I think everyone will be. I think everyone backs him on that. He noted that the lunar lander still needs to be designed, built, and tested, and 2024 is a very close deadline for all that to happen in.
Definitely.
And he said, this is a direct quote, that is a hard challenge on a 5-year timescale, even without political budget infighting.
Yeah. Something that should be kept in mind is that back then, when the space race was, live, it was during the Cold War era, and there was a lot of incentive, national incentive, to actually beat the Soviet Union to the moon, and the Soviet Union wanted to beat the US to the moon. So that incentive was in place. That's what fueled the space race. Nowadays, we don't have that kind of Cold War.
Thankfully, we don't have it.
Yeah,
but yeah,
we don't have
it
the
does
Cold
reduce
War.
the incentive.
But what is the incentive now? What is the rush for us now to get back into space?
Yeah, because at the end of the day, back then, it was a head-on-head fight with the Soviet Union to get there. But people looking at this space race will say it's just Trump trying to accelerate or trying to stay in office, basically.
I mean,
So
at first, I did think that, but then I realized every single president has said something about space.
But no, every single president does. But this is the point. Trump might not be different to any other president because there was no incentive back then. There's no incentive now. Will he even succeed with the mission, or will it just fall by the wayside like they have in the previous years? So yeah, incentive is a big one. When a whole country's fighting against another country, I think stuff gets done quicker.
Yeah, but let's move out of politics and into engineering. Let's discuss some of the possibilities, address some of the concerns, and we'll look at the technologies, the old and the new, that will actually help us get into space and onto the moon.
So I think the old technology we'll get into first because it was such a massive feat.
Yeah, old technologies. So we'll mainly be looking at the Saturn V rocket. This was in 1969.
Yeah, Saturn V and Apollo spacecraft.
The Apollo spacecraft, which famously had Neil Armstrong, Buzz Aldrin, and Michael Collins on board. So these three astronauts, two of which were the first to land on the moon.
Yeah, and Michael Collins, poor man, is always forgotten, but we'll get to that. It was a massive event. It was watched by 600 million people on the world. I was there on Earth, and yeah, it was ridiculous. Back then, obviously with the Soviet Union and the Cold War we were just talking about, astronauts, especially Neil Armstrong and Buzz Aldrin, were treated like rock stars when they came back from the moon.
Now, obviously, it goes without question that a lot of people think this is a hoax. A lot of people think that there's some sort of conspiracy going on about this. Did they actually make it to the moon? Is the footage real? Etc. Etc.
Not our place right now to say that. But
yeah, this is not a conspiracy podcast. We're going off the basis that yes, let's say they got to the moon, and this is the technology that got them there.
Yeah. So the distance. This is for conspiracy theories. This is one of the things I always bring up. The distance from the Earth to the moon is around 240,000 miles.
But these astronauts wouldn't have covered that distance alone. They would have covered a lot more.
Because
there was orbits going on.
Yeah.
It wasn't a straight trajectory path to the moon.
Yeah, we'll get to that. So the Saturn V rocket and Apollo spacecraft had 5 separate stages. The first stage had a thrust capacity of 7.5 million, and it was developed by Boeing. So that's when I just saw put that one in there.
The second stage that had a thrust capacity of about 1 million pounds, and that was developed by North American.
The third stage had a thrust capacity of 200,000 pounds.
Fourth stage was the main bit. So this is the Apollo spacecraft itself, and the spacecraft was made up of 3 different modules. The spacecraft was made up of 3 different modules. So the first one was the lunar module, and this was the section that actually landed on the moon, hence the name Lunar.
Yeah, that's the one that took Neil Armstrong and Buzz Aldrin to the surface of the moon. Service module. So this module was an important one. It was for course correction and propulsion systems whilst they were on their journey.
And finally, you had the command module, and this is where the astronauts spent most of their time throughout the journey. This is where the command center on board was.
Just to give everyone a bit of a perspective of the whole rocket and spacecraft, the Apollo spacecraft itself, so the small bit which took the command module, which as you said housed the astronauts for the big journey, that was described as like a ladybug on a car. So that's like how, the size difference between the rocket and the actual command module where everyone sat.
Yeah.
And that little part was what made it back to Earth.
And the last and final stage of the rocket, which is the tiny little spike at the top, this was the launch escape system. So essentially, this was just an escape chute designed if anything happened in space. Once you're going up to orbit, once you're getting up past the atmosphere into orbit.
Yeah. If anything went horribly wrong, it would try and pull the astronauts away and keep them safe. Is what it was designed for. So it's all well and good saying that there were 5 separation stages. I think we should sort of explain what the separation stages were.
Yep.
So the first stage was the largest in size. It took the rocket 42 miles above Earth at a velocity of 6,000 miles per hour. So it accelerated 6,000 miles per
These
hour.
are the big rockets, you know. These are the ones that people look around, will stand around for, and you know.
Yeah, this is
this is
the
the
one
countdown.
Countdown.
10 seconds, and then bam,
all
you hear
that-
the big, the loud noise, the vibrating ground.
Yeah, and a lot of fire under
That's
the
the
rocket. This is
that's
that
the
big
stage
first
one.
stage. Yeah.
Stage 2 took the rocket 103 miles above the Earth's atmosphere, and then this was when the launch escape system was actually jettisoned, so they don't need a button at this time. So they actually it just detaches and gets thrown away.
So now that they're in space, stage 3 of the rocket was designed to put the Apollo into parking orbit, which circulated the Earth 9.5 times, 103 miles above the surface, as you said. This was obviously done to just make sure all the final checks were in place, make sure that everything was all ready to go, and then it was catapulted around. So once it was at the optimum stage, it was catapulted off the orbit of Earth and into deep space.
Yeah. Now it's the fun, exciting parts. So it's called the lunar module maneuver.
Mm-hmm.
So now what you've done is you've removed the first and the second part of your spacecraft.
And
you've now got the 3 remaining bits.
Yeah. So stage 3 is now hurtling into deep space. Yeah.
The lunar module maneuver is protected. The lunar module is protectively stored inside the third stage.
Yeah. It was. Yeah.
So what happens now is the third stage breaks away. It does a complete U-turn, and this allows the lunar module to be accessed by the
command module.
command module.
Mm-hmm.
These two attach together, and then the third stage is detached, and the rest of the craft continues on to
the moon.
towards the moon.
Yeah, exactly. It was a very complicated process, and it sounds like a long process, but it actually only happened in 3.5 hours. So that this is just recapping from Earth into the orbit around 9.5 times, catapulted off, and then this lunar maneuver where they pull out the lunar module from this third stage, jettison the third stage, and then turn around to go to the moon.
Yeah. All in 3.5 hours.
Yeah.
But now it's the long wait.
Yep.
It's 3 days of just coasting towards the moon.
Yeah. So they had set the trajectories, and that was it. They're just coasting their way there.
After which you get pulled into the orbit of the moon, and this is when the crew begin to split off. So they get into the orbit of the moon. They start circling the moon a few times whilst they prepare themselves to land onto the moon.
So this is, as you said, where the crew split up. Armstrong and Aldrin, they get into the lunar module, and it was called Eagle. The Eagle will then go on to land on the moon. There's a fun fact here. It required a bit of manual maneuvering by Neil Armstrong. And when they came back, they said it landed with only 25 seconds of spare fuel left.
Yeah, so it's supposed to be an automatic system that actually lands them on the moon, but they were already quite off. So
yeah, they had to course correct and get back.
And that's actually where the famous quote, "The eagle has landed," comes from, as well as, the one small step for man and the one giant leap for mankind. Yeah. All of which was happening to Neil Armstrong and Buzz Aldrin. However, where was Collins? Poor old Collins. He stayed in Apollo. He stayed in the Apollo spacecraft, which is circulating around the moon. Yeah. And this spacecraft was called Columbia. But essentially, this just made him the most determined and patient Uber driver the world, not even the world, the universe has ever seen.
Yeah, pretty much. He took him all the way there and stayed in the car while
he was a glorified taxi driver.
Yeah. Everyone rate him 5-star on Uber, by the way. Yeah.
Imagine getting all the way to the moon and not even having a chance.
Poor Michael Collins. He's always the man who's forgotten because he was the one who stayed.
And imagine for 21 hours. Yeah. So the two astronauts went onto the moon, and for 21 hours they were there doing experiments. They left some memorabilia from Earth,
collected samples,
pictures, and they did all of that. And in those 21 hours, poor old Collins was in the module alone. No one else was there to be with him.
Yeah,
you can just imagine what's going through his mind.
Poor man. They also left some interesting stuff. You did say they left some memorabilia. They left, I think, pictures. Languages as well.
So recordings of languages across the world.
And that's, I'm assuming, all in the hope for extraterrestrial life to find it and to communicate with us or whatever. But yeah, Again, not a conspiracy theory channel here or podcast. So, yeah. So after 21 and a half hours on the moon, Eagle launched from the first celestial body that wasn't Earth to rejoin Colin in the Columbia, in orbit. So that's a really interesting bit. It was the first time anything had launched off of something that wasn't Earth. Yeah, which is really good. A planet that wasn't Earth.
And this was just literally a small propulsion, little rocket that just burst underneath the lunar module, and it shot the module up into space again, and perfectly timed with reconnecting with the Columbia
module.
The Columbia module. This then obviously ditched the lunar module. There's no need for it anymore. And now all 3 astronauts have been reunited. This is when the trans-Earth injection now takes place, and essentially just like how the module got from Earth to the moon. Now it's the same thing, from the moon to the Earth. They're being catapulted around the moon, back into the Earth's atmosphere.
Yeah, and that's
Earth's orbit. Sorry.
Yeah, and that begins the 2.5-day journey back home. So, upon approach to entry point at Earth, the service module was no longer needed and jettisoned as well, leaving only the command module to re-enter the Earth's atmosphere, exposing the heat shield on the bottom, which would protect them on re-entry.
Mm-hmm. And then finally, the Apollo module returned to Earth through its atmosphere at a staggering 25,000 miles per hour. Parachutes were deployed, slows the craft down to about 20 miles per hour, and then it lands safely in the Pacific Ocean. So the lads actually had to be quarantined for about 21 days after this. Obviously, they were exposed to radiation, and they still don't know what is out there, especially on the moon. So they were in quarantine for about 21 days, getting rehabilitated.
So just giving a quick, an insight into the magnitude of this whole thing was the Saturn V Apollo spacecraft. It started off at 3,000 tons of fuel and freight, and at the end, when the command module landed, it was just a small craft carrying the 3 astronauts and a few samples of rocks from the moon. So.
Yeah. Another thing that we should point out is the spacesuits that these astronauts were wearing. Obviously, they can't just be going up there in normal clothes that you'd be walking around in over here on Earth.
So the spacesuits, they had several layers to the suit. The inside was a sort of long johnish fabric, so that's a weird way of describing it. But yeah, it included cooling water tubes sewed to the material to keep the astronauts cool while working on the lunar surface. After that, several layers of nylon, Kapton, glass fiber cloth, mylar, and Teflon were used to maintain pressure and protect the astronauts from radiation and micrometeorites.
Astronauts also have special lunar gloves and boots. These were introduced to help the astronauts walk on the moon's surface. They were able to pick up rocks and other different samples that they needed. It makes the astronauts able to feel things as well. That's the main thing. So they need to know what they were picking up. Attached to these suits were polycarbonate helmets, which also supported life support systems, and a backpack that allows astronauts to breathe and maintain suit pressure for up to 7 hours on the surface. All of this hailed a massive engineering feat back then and until this day, actually.
Yeah, it's set in history as one of the biggest engineering feats ever. So moving on to the new technology, how will it cope? How will it fare? How will it compete to the old stuff? Thanks for that. So NASA have said that the new rocket will need to be a larger, more powerful rocket than the Saturn V, which is quite obvious. Also, one of the main differences with this new rocket will be that they'll try and use reusable solid fuel booster rockets, similar to those developed by SpaceX for their Falcon spacecraft series.
Yeah. Just touching on SpaceX again, they are also developing a BFR system, which is booster transports. Essentially what this is that the booster transports will take a ship into orbit and then release that ship. The boosters will then return to Earth and they'll be refueled, where they can then be sent back up into orbit to connect with the ship and refuel that ship
for longer journeys.
Yeah,
so it's quite a good feat, quite a good engineering idea.
Yeah, I mean, what the point is with SpaceX, that they're looking to meet the needs of any mission, not just particular going to space, going to the moon or going to Mars.
And that is very important. Just touching back on what we said about the presidents changing their mission every time. So if you're developing a spacecraft or a rocket to go anywhere and everywhere, no matter what happens or no matter which president and administration comes in at that time, you can meet the needs. So it's,
Yeah.
it's quite a smart plan. But yeah, just touching on the spacesuits as well. The new suits will make it easier for astronauts to move. They will better protect the astronauts from dust. Dust can be rough like sandpaper, so it can really hurt. And the new suits will have parts that can be swapped out as well. So on the modules, I'm assuming they'll store them on the modules and be able to swap them out if they're damaged.
Going back to the spacecrafts will also have escape systems that should enable astronauts to survive a launch disaster. This is a feature that was actually absent from the shuttle, giving the ill-fated Challenger crew no chance of survival in 1986.
Atop the rocket will also be a manned lunar module, similar to the one on the Saturn V and Apollo spacecraft. It's obviously going to have to be larger. They want to try and fit more people in it and bring more samples back. So that'll be the main focus area there.
Yeah, and then another big, massive, obvious point is that back in 1960s, 70s, and 80s, the computing power that they had back then was a lot less than what we have right now.
Minuscule compared to what we have.
I mean, back then they were talking about on their moon lander, they had the processing power of 64 kilobytes.
Just to put that in perspective for you, if any of you listening have had a PlayStation 2 in your life, the memory cards on them used to be 16 megabytes, which is still nothing compared to this day and age, but that's more than what was on the moon lander.
Exactly. And that 64 kilobyte processor, that weighed about 30 kilograms and used about 55 watts of electricity.
Yeah. So yeah, the computing power will be substantially more. I'm hoping there'll be better camera devices on there to get some footage back and try and quash all the rumors of conspiracy, but we'll see what happens. But yeah, I guess that brings us to the end of today's chapter. Apologies on the new technology of the spacecraft. There's not much out there, of course, because NASA is starting this feat now. Again, this is one of them things which will be going on for the next 5 years, and
it's something that's still in development.
Yeah.
And I think the biggest thing to look out for is SpaceX having those reusable rockets.
Yeah.
Coming back to Earth, and you're able to refuel them, saving on a lot of costs with that kind of project.
Yeah.
So in terms of new technology, that is where the space agencies are heading.
Yeah, and as we mentioned previously, NASA and SpaceX are now working together on some missions and some projects. So yeah, a lot to come from them, I guess.
Yeah. Well, I hope you enjoyed the episode. As we mentioned previously, from here on out, this is going to be our format. We'll be talking more about topics that are engineering related, current topics, and we'll make sure that we make them as engaging as possible.
Yeah.
Which, if you go towards our Twitter, hopefully you have been engaging with us. There's a couple of quizzes out there.
Yeah.
We will be putting up articles and things that we find interesting, something that takes our fancy in the engineering world.
Hopefully we'll get some quizzes and articles out there relating to the podcast we've just done, so get on them, have a vote, see what you think, and yeah, just get in touch with us, let us know how we're doing. If you enjoy them, make sure you let your family and friends know about it as well, spread the word.
And subscribe, get in touch with us, subscribe, comment if you're on YouTube, on Spotify, just get in touch with us, let us know how we're doing, and hopefully we can keep creating this content, making it better.
Yeah, and the more you comment and the more you let us know how we're doing, the better we can make it for you. So it's very important. But yeah, thank you for joining us on this chapter of An Engineering Odyssey.
Thank you.